All right, everyone. So today, let's have some fun by building a contract that facilitates transaction between a mortgagee and a mortgagor. And so let's give it a start. Let's use 2.5 contracts. Let's name it mortgage. But before this, I intend that we should create a contract for the mortgagor. So let's create a contract up here. Let's name it must call. As we go further in the architecture of the small code base, you kind of understand it better. So let's say now we can inherit it and say mortgage is must call. Let's move ahead. Must call. In Solidity, you cannot call must call directly this way. You have to rename it in the mortgage contract. Then address mortgagee. What other address do we need? Address mortgagor. What else do we need? We need a mapping to track the balances. Here, what we did was that we mapped the key. No, this should be address. No, not balances. We mapped address to the value of your interfaces, meaning that in each address, we are tracking this data type of Ewings. Let's move ahead. We have to initialize a couple of things in the constructor. Let's say mortgagee is mortgagee one as are the first mortgagee in the contract. Then we need to initialize the must call contract above. So we have to say must call is must call. Yeah, since that is out of the way. Now we haven't declared this. If we click on this now, it is showing undeclared identifier. In Solidity, when you see an undeclared identifier, it simply means a variable you have created, you haven't really defined it before calling it. And you have to define stuff before calling them. So come into the argument of the constructor here and say address mortgage mortgagee one and address must call. The reason is because the must call contract we are trying to initialize an address, then the mortgagee we are trying to also initialize an address. That's why we use address mortgagee one and address must call. And you have to ensure that these things correlate so that there won't be an error. If there is an error, it will show you undeclared identifier. Now let's write a function for deposits. Function or gauge your deposits. You have to mark every address that receives ether or gives out ether payable. Balances of msg.sender, msg.value. This clears it. You can put require here that if msg.value is less than 1 ether, say you cannot deposit. Revert. You cannot deposit. To do this, we will have to create an error here, the custom error. Good. No. Yeah, this is better. Let's move ahead to the withdrawal function. Function withdrawal. Let's create a function in mustCall. So we can say function communicate mark it external so other contracts can pick it up. Let's move on from here. We should put a check here. And as you can see, we haven't created this as a local variable or as a variable within the parameters of withdrawal. We just picked it now. You can use the undeclared identifier. So how do you solve that? You can simply come here and say you're 256 or any form of unit you want, say amount. That fix is it. Then how do we put a check here? Require msg.sender equal to nullity. Oh no, let's rewrite it. Let's use a modifier instead. So we can simply require that anyone that can call this address must be a mortgagee. So let's say mortgagee. Then this is call it. Okay, let's read the error or the last one. Then we can say let's try to check what we name mortgagee as above. Okay, there is right. So pay through MS to the sender, transfer can go ahead for a couple of getter functions. So I think a modifier will just do this. So let's go ahead to create a modifier that we'll need in the withdraw function above. You can simply say first you hand your modifiers with the lock. Then we can call it above and say mortgagee only. Yeah. You should be able to know the contract balance, so we can create a function for that. Contract balance. The getter function should return. So public view returns. What do we want back? We want to get the balance, which will be in form of units. So unit 256, more specifically. Then we want to return address this dot balance. If you check this contract, you see that we probably need 2.8 is the latest one. Okay, let's use 2.8. How about that? You can see that we didn't emit events, and you need that for your front end to sync properly with your smart contracts. Let's try to come up with a few events and show it up. So let's create an event for withdrawal. Let's go to withdrawal. Since it's a critical function, no, this should be address this of dollar. All right. So address this of dollar. Let's create the events. After the calls have been successful, we can say emit withdrawn. And withdrawn can be MSG the sender. So the details we need MSG the sender and the amount. Let's go to deposit as well and say emit deposit. MSG the sender, MSG the value. Let's create this event. Events withdrawn. Address index mortgagee. Then you're in 256 amount. Event deposit. Address index. You can say color, you're in 256. Any error so far? Let's try to run this up and see if compiler will compile it. Okay, cd point for P. Okay, as you can see, there is an error. Let's try to fix this up. And there you have it. It's successfully compiled. Let's not stop here. Let's also test out this contract with Foundry. So you can come here and create mortgage.c.so. Let's try to set up a Foundry test. Of course, Pragma Solidity 0.8.25 import forge std test.so. This is the Foundry dependency we will actually need to test out our contracts to call the cheat codes. So since mortgage.so is here, you say dot dot src, that's the path. Contract mortgage test. In Foundry, this is how you say it. Test is test. Then let's create some variables. Must call as well. Or better still, this is how I do it. I split my screen into two so you can see your programs or your contracts concurrently. So this is the actual contracts. These are the variables. Let's move on. Address. Then let's create another one. Address this. Since we also want to test if the events emitted as we want, we'll also have to paste the events right in the contract. Oh, this should be inside the contract or in the test file rather. You can simply copy it or type it out. Anyone that works. Then we have to set it up. This setup is similar to how Remix works, such that you have to impute parameters into the constructor. So this is how to do that in Foundry, and we call it setup. By using new, we are creating new instances. Now we should give the contract or the mortgagee address 10 ether for testing purposes. And in Foundry, we use VM.deal for that. Test mortgagee deposits. You have to call the prank cheat code, so you can set who you want to call it. So the value 1 ether. Then this is an assertion. So assert that the balance of the mortgagor is 1 ether. Now let's move ahead to test the withdrawal. We can say function test withdrawal or test withdraw, however we want it. Public vm.expect call. Since we're expecting cross contract call and code with signature, communicates. And move ahead. We are expecting some emissions as well. So we can say VM will expect emit address gauge emits withdrawn. Now let's do the actual withdrawal. Let's assert equal. This assert EQ means left and right are of the same value. The balance of the mortgage or the mortgage contracts is 9.5 ether. I mean, since the mortgagee has withdrawn 0.5 ether, the balance of the contract should be 9.5 ether accordingly. You can say VM.stopRank and you end it with VM.stopRank, or say VM prank and not bother to say VM stop rank, but we'll go ahead with the second one. Let's try to test it out. And after a few minutes of debugging, you can see that our contracts, the two tests passed for withdrawal and for mortgage. I hope you learned from these guys. If there is any other thing else you want me to cover in development, smart contracts, research, or anything, do let me know in the comments. And thank you.